Hello, this is the second part of the videos creating a simple game like this. So one more time, if I start the game, I say N. So this is the aim, something like this to start with. Then we can improve this game later on. And yeah, hit like that. Game over, 33 points. And in the last video, this is where we finished. If I run this now, we created the renderer, so we separated the drawing code, so it's independent now from the rest of the code, which is good. And obviously I say hello. Let's change that to player. It looks a little bit better. Before we start this video, let's just make it a little bit nicer, so it looks better now. So in the previous video I was kind of promising that we're gonna do, in the next video we're gonna do, you know, these chunks falling randomly from there, but I was just looking what we're gonna have next, and there's something before we can start doing that. We need to create a couple of structural things, so I don't think it's gonna happen in this video yet. I want to talk about a couple of design things, because when we're creating a program, we want to always design first, isn't it? If we are good programmers, we design things before we start even coding, and I think this is a good idea to do. So let's design a little bit here. What we want to do in this project is we want to be able to have this console window where we run the game like this, and let's say that the player is here, and then, you know, they're falling, the chunks are falling like this, and this is the player like this. And now what we want to be able to do is that we have different games. So this will be game let's say game 1. We run game 1, and then we want to be able to create another game object at the same time, that we are able to switch from the first state to the second state. So let's say that in second state the player is here, and then the chunk is falling like this. So we are able to have different games running at the same time. It's not necessary that we ever do this actually, but from the design point of view, it's good to create such that we are able to run multiple games at the same time, and if at some point we want to do this, we can do it. Anyway, even if we don't want to ever do this, it still makes the game, the program structure better if we do it like this. That's my argument here. Plus it gives the option us to run multiple games at the same time, like let's say 5 games at the same time. At a certain point we can stop running this one, and then we will continue from this state, and then we will stop running this one, and we will go back to this one where this was. So it continues from the state where it was before, and we can switch the games in the same console window. I don't know if we can have multiple console windows, but at the moment let's do it such that we have only one console window and we can run multiple games. So that's the target here. Okay, let's talk about the game loop next a little bit. How will the game loop look like? First of all, we want to have a constant time for each frame. One frame is always one situation in the game world. Let's say that the player is here. Okay, the player is here. The player is about to move, let's say there. So then we will get the new frame where it moved there, like that, something like that. So this is frame 1, game frame 1, and this would be the game frame 2, and so on. So there's a small time step, and in this game I will be using 60 millisecond a time frame time, millisecond. That's what we use first, 60 milliseconds. So the time between these frames is 60 milliseconds. So this thing moving from here to here takes about 60 milliseconds. So we want constant frame. So from this situation to go this situation, we want to have constant 60 milliseconds. And if we are going to the frame number 3, again we want to have that we want to draw it in the next 60 milliseconds, and so on. Because currently what happens, actually, if we are looking at this currently, how we have it, we have a while loop and there's nothing to stop here, anything. It just runs as fast as it can. So if you have a slow computer, this will probably run a little bit slower, but if you have a super fast computer, it would actually run it very fast probably. And when I'm moving this player, for example, it will go super fast from left to right. That's the problem currently we have here. So we want to make the movement constant, that regardless of the computer, we want to always move the same amount, 60 milliseconds always. Okay, and the second thing we want to do is that we want to have a good structure for the game loop. At the moment, here is the game loop, and we can see that there's some code here doing the keyboard, and then we have the rendering here, and then we have some kind of change of the position of the ball. But we want to have a better structure now. What we want to do is that we want to first update the input. Okay, in this case we only have the keyboard input, so we have keyboard input update. Then after that we want to do update logic, the game logic, update the game logic, and lastly we want to render. So this is the loop. So we're gonna go update input, update logic, render, update input, update logic, render. So we keep looping this thing forever until the game ends. It's that simple. The logic is that every 60 milliseconds, it takes 60 milliseconds to update the state of the game. So we are not moving anything faster than that. So we need to keep this one in mind all the time, that the update of the position of each player and everything and all the objects needs to have a constant update. Okay, so let's start doing this now. And here is the current version. So this is the version from the last lesson, and I already created a new file. I call it Space Slalom version 2. One thing we want to do here is that we want to have a game class, because we already were talking about that we want to be able to run many games likely in the future. So let's create a game class where everything happens. Okay, instead of running things in main and in global functions, we're gonna have a game and then start the game from there. So let's create the game class first. In the construction function, we want to initialize certain things, and we will come to that in a moment. And then, as we already talked, we need 3 functions, which are gonna be update game logic, update input, update game logic, and render. So the game needs to have those things into the game loop, and then we need to have the game loop. I'm calling it at the moment run game. So the run game is gonna have the game loop, and then the game loop needs to end at some point. At the moment we have here while true, so it never ends. But we need to have an ending condition that we will end this loop at some point. So let's create a Boolean variable for that. And then one more thing it's good to have here is the playing area. At the moment the playing area is everything, but let's just create a rectangle now that we can limit the area where we are playing. So to do that, let's create a rectangle object, playing area rectangle. Let's initialize the playing area rectangle first, like that. So these are characters. So the left of the rectangle, playing area rectangle, will be 10 from the left, and top is almost at the top, just one row down, and the right will be 105 and bottom 28. So 28 lines from the top will be the bottom of the playing area. Okay. So I guess we can start creating these other functions now. Let's create the game loop first. Okay, so what do we need to do here? So we need to have that while loop there. We will run the game until this boolean value becomes true. So we can put not until not end game. We keep running the game. And then we wanted to have that that 3 condition. I think I still have it here, do I? Yeah. We want to have in the loop, in the game loop, we want to have update, input, update logic, and render in that order. So I'm gonna put it here now. Like that. We will update the input, always update the input first, then logic, and then we will throw everything lastly. But all of this should happen in 60 milliseconds intervals. Okay, so that's what we are aiming here, that we have a 60 millisecond interval. And to do that, we need to have some kind of time now, and in C++ we can use the chrono time. Don't need to worry too much about what this all means, but I will just tell the basic idea here that we use the C++ chrono steady. It's kind of goes forward all the time steadily. We take the current time. So the previous frame time, we initialize the current time, and also the current frame time now. The logic of this thing goes like this. We have the time here, and these are the time points, 60 millisecond time points. So this is start 0, this is 60 millisecond, this is 120 milliseconds, and so on. Okay, so we start from here, and the current time is 0, for example, and the previous time is also 0. How we start here? Well, it's the now. They are the same. It doesn't matter. Well, actually, it doesn't matter what time is here. Let me put 100 here, so it's a little bit easier to understand. So this will be 160, and this will be 220. Okay. So let's not start from 0, so it's more clear what's happening here. So this will be 100. Okay. So if we start from here, then both of the times are the same. And now let's say that we have 50 milliseconds gone. We are here, so we are checking that if current time, so now the current time is here, updated. It's not anymore 100. It's here now. Current minus previous. We are checking that time period. Well, it's 50 here. 50 gone, so we do nothing. But when it becomes 60 here, so if if the current minus previous is greater or equal than 60, then update. Like that. Then update everything. And then draw and everything. And then we need to update also the previous value to be the current. Because the current is now here. Current is here. So we need to update the previous so that the previous goes now here. So the previous becomes 160. And then we will do the same thing here. So this is the logic. We always need to update the previous to be the current when we hit one of these cornerstones. Okay. So let's do that here. So first we can update the previous frame time to current. And then we will wait for the next 60 milliseconds. And here I need to do the if thing here. If something, then if 60 milliseconds is gone, then we will update everything. Okay, now we need to calculate the 60 milliseconds. These are time points. So we need to calculate the that how many milliseconds has gone. So this one minus this one, we need to calculate. And the way to calculate that in C++ is, okay, I'm updating always first the current time here. And then we need to calculate that how many milliseconds is gone. And this is the way in C++ it can be done. Again, don't need to worry too much about this, but the way it works roughly is that we are asking milliseconds here. There are 2 time points and we are asking millisecond difference. So current time point minus the previous time point, and then we are asking milliseconds, and then the count gives how many of those milliseconds. This is how this long thing works here, and we will finally get the amount of those things in milliseconds. And now we are checking here if this milliseconds is greater than 60. Then we will update everything, and we will update the previous time to be the current time. And then we will render also. And like in the previous version, we need to initialize the globals. These ones, initialize the renderer. Let's do it here in the main. And in the new version, we have to do everything in a game. So let's create a game object here in the main. Game. And then we will run the game. Run the game. Okie dokie. And there the game loop starts now. And until this becomes true. Okay, let's next do the render function. And the render function will be, look at the old version here. So in the old version we did the rendering like this, these 3 lines. So we will be doing something similar now. So let's just copy and paste the code here. Let's comment this out because something new is coming in a moment. And then we need to have the update logic. Let's create the frame of those functions first, and then start creating the implementation. We will put the implementation here soon, and then we have the update input. There is one big thing we're going to add now next, which is we're gonna create a class called moving object. The reason is that we need to be able to nicely handle all these objects, because we're gonna have many objects running there. At the moment, if I run this game, we have this player here, and then we're gonna have a lot of those chunks, and in the future we might have other things coming here, isn't it? We might have bullets or something. So we have a lot of things moving here, and now we need to have a good structure to create these things. And let's have a class called moving object, which is able to do all of these kind of. So let's go and look at that, what kind of class it needs to be. I'll start creating that class now and explain as we go. So and I will put the comment here, and let's look at the comment. It's good to have a comment. This class needs a good comment in my opinion, because it's a little bit more complicated. This represents a moving object, and all the functionalities to do the moving. Like we need some kind of hit test maybe at some point, not at the moment, but later on. And it will store the speed of the object, the current speed of the object, and the direction of the object. So when we call move, it's able to move to the current direction with the current speed. So but we can also set the position of this moving object at any point. Like I want you to go to the position 110 right now. So we should be able to do all of this, that we can ask it to move one step to the right or left. Let's look at that next, actually. So let's say that the object is over here. What we want to do is that we want to be able to tell this object that, okay, move right 3 steps, something like this, and then this thing will move over there, isn't it? 3 steps. Yeah, we want to have this kind of function. We also want to have a function like set or set position, and then we will say like, okay, 33, and it will move it there, 33. Yeah. And what else we want to do? Then we want to have a function also. We will just say that move, yeah, just move, just move, and it will go to the direction where it was going with the current speed. Like let's say that the speed currently is 2, okay, and let's say that the current direction is right. So if we say move, that means that it moves from the current position 2 characters to the right. So we want to have all of these functions so that it's very easy then continue developing this program. So let's start creating these things. In order to do the direction and stuff, we need to first have a helper enum here, which is going to be called direction. So this enum defines where are we going at the moment. It can have 4 different values: up, right, down, left. And now this moving object will have 4 different member variables. The first one will be how the object looks, its shape, its size kind of thing. So this could be the, for example, the like hello, for example, hello. It's the one which is moving there. Like in this case, it will be 3 stars. Okay, and that's the position. We already defined that position in a renderer here, x, y. And then we have the speed. The speed means that how many characters we are moving next time to certain direction. And this is the direction where we're gonna move. And here's the definition of the direction. Let's create first the constructor function. So we're gonna pass the body of the object here, the characters, how it looks, and then the starting position and the speed, by default speed 1, and we will push all those values into these member variables. One of them is not initialized. Which one it is? Position, speed. Aha, the direction is not initialized, but I'm not sure if it needs to be initialized, because we can set the direction with the function later on. So let's see if we need that. I'll leave it for now. Okay, and then we need to create the move function. So there's going to be many move functions. So let's create the father of all move functions, which is this one. And I will soon show how we can nicely use this. So this is the parent of all other move functions, that we can move this much to the like horizontally, and this much vertically. So we will just add them to the position, and then we need the other helper functions. So we are moving x. So this is calling this function. So the idea is that all the other move functions will always call this one. That's a good way to do programming, that we are not repeating anything. We are calling one which works. So we make sure that this one is perfect, and then the other functions are reusing this one. That's a good way to do programming, that we are reusing the old code. So we are moving now vertically here, and then we can move using the current direction. So this is the move which moves using the current direction and the current speed. So we are checking that what is the direction. If we are going up, we are moving vertically, and it's going to be minus the speed, and so on. And then we have a move function that we are telling only that which direction we want to go next. So it will only change the direction, and then it will go to that right direction with current speed. Okay. And then we want to have a function called set position. We can jump to any place on the screen, and then we want to have getters also, so getting the current position. And because we want to draw it, we need to get the string, the object string, which we're gonna print on the screen. And then we want to be able to change the direction, and then the same but the get direction. And then for the speed, setter and getter, set the speed and get the speed. And one more function probably is nice. I like this function that we will get the width of that object. Like if we have hello, it will return 5. So it's the width of the how many characters the string is, rather than calling this length. It's a nice helper function there. Okay, so now we pretty much created this moving object, and let's start using it. So we're gonna have, in the first version, we're gonna have the player, and we're gonna have the ball. Maybe let's do the same thing what we did here first, that we just gonna have the ball, or maybe I call it chunk this time. I call it chunk. We have one chunk falling from the sky, and so the moving objects are gonna go into the game. Let's go to the game, and let's create first the player. Put it in a private section. So I'm gonna call it player, and okay, now the moving object, as we just created it, it will take the shape of the object, the position, starting position, and the speed. And so the shape of the object, the starting position, and let's put the speed 2, and let's make the speed of the chunk only 1. I just tested it and it's better like that. So there's the chunk star, and it starts from the top 0 there, and speed 1. Aha, okay, now this position actually, let's make so that the player is starting from the middle of the playing area. So we can do it here in a constructor, not from 10, but let's put it nicely in the middle of the game area, and maybe at the bottom somewhere. So it goes like that. So left plus right divided by 2. Okay, so this will be, I need to put here left plus the width of the playing area, which will be right minus left divided by 2. So right minus left divided by 2 will be the width of the playing area plus the left. That should put us in the middle of the playing area. And then we're gonna go 5 rows from the bottom upwards. Okay, let's see if this works. I just did it here live, so hopefully I got it right. So that should make it in the middle of the game area, at the bottom of the game area. Okie dokie, so. And let's now do the update input. So the update input function is updating, you know, the keyboards. We are pressing the arrows, and it should update the player's position in this case. So if we go here, so where was the I think this was the code we created last time in the last lesson. So we can kind of copy this code from here, the keyboard. So now it goes to the update input function, all of this. It will be similar now, but I'll put the version here missing. I didn't put it there yet. So I think if I go here and copy that function, put it at the top here, the global function checking the virtual key, that was it pressed or not. Yeah, now it works. So the update input has been done, and now update logic. So the update logic at the moment will be only that the chunk is going down, and then it's gonna go back to the top. This is the logic actually at the moment. So that the ball is, when the ball hits the bottom, it will go back up. That's the only logic we have here. So let's do that. So first of all, we will move the chunk downwards. Now we have this nice function move y, so we're moving vertically one down. Actually, we don't need to say 1. We can set the speed. The speed is already 1, isn't it? So actually we can just say move now, as long as this direction is correct. So we need to set the direction. Let's try that straight away. So let's say that the direction is downwards. So we can say here in a constructor that set direction, and let's go down. So we need to go direction, and where is it? Here. So for the chunk we want to go down. So I set the chunk direction, it's always going down, and I also said that the speed is 1. So now we don't need to call, we don't need to tell how much we're gonna go and what direction, because it already knows. So I only need to call move and it will automatically go down 1. And let's check now that did it hit the bottom. If it did, let's go back to the top. So if the position y of the position, which is the vertical coordinate, is greater than 22, for example, then we set the position to be the current x, so the current horizontal position, and we just change that y is 0, which means that it's back to the top. Okay, that's the logic at the moment. And what else? Aha, yeah, we need to now render all this stuff. Okay, so the rendering needs to be, it needs to be using now the 2 moving objects we created here, like that. So we are getting the characters from the player and send them to the renderer, and also the position, and the same thing with the chunk. And if I'm lucky, there might be everything now. Let's see what happens if I compile and run. Okay. Looks promising. Goes up. It's right. Yeah. So as we can see, it's not a different than the previous lesson version, but it has significantly better structure now. So now we can easily add more objects here. It's easy to now add more objects and continue from here. So everything is now in place. And one more time, yeah. So it's good to continue from here, and in the next lesson we will start now adding the chunk, more chunk and stuff, and start improving this more. Thank you for watching, and see you in the next video.